Hey everybody, it's Ben again talking about using some software and web pages to design our solar system. I designed and installed my own solar system on my garage. Right now I want to show you about a design tool from Iron Ridge. That's a racking company. We already showed you how to use the PV watts calculator and use the solar kit guide or solar design tool on renvu.com. And later I'll also show you about a solar design tool. So right here at ironridge.com, there's a lot of information here, the parts catalog, all those sorts of things. But what we want to look at is the design assistant. Now keep in mind, like a lot of web pages, you do have to be logged in or start a new account. I already did that. So let's go to the design assistant. And first thing we have to do is enter a new name for the project. One reason why that's important is with your login, it will actually keep track and save your project. You can also create multiple projects. So maybe you're not sure exactly what you want to do yet. You can design more than one project and have some variation between the two to help you decide what it is you want to do exactly. If I go to my projects, you can actually see a couple of projects. I worked on a couple different variations of my solar garage until I had it quite the way that I wanted it to. We can also right here start a new project as well. So this one I'm just going to call the solar sample 2, but we'll use basically the information that I used for my garage. First thing they want to know is where are you? It's already set up for US zip codes. I'll put in my actual zip code. And some of this information over here is actually automatically populated already just based on your zip code. We do have winters here with snow, so we've already got some information in the ground snow load, and we also have some information in the wind speed. Wind speed is of course important because the racking is the entire system that holds the solar panels to the roof of the garage or to the ground mount or the roof of your house, wherever you have it installed. Now, we don't get hurricanes where I live, but we do get tornadoes, and 100-mile-per-hour wind speed is certainly possible in our area here. This information is pulled up out of weather databases, but if you live in a special area, if you're on the coast, you might have to deal with higher wind speeds. And when in doubt, talk to your local building authority. A building inspector isn't just there to tell you what you can't do or punish you or things like that. Building inspectors can also be very useful resources. So if you have any questions in terms of what you need for wind speeds or snow loads, go ahead and ask your local building inspector about that. Ground snow load. This is the correct snow load in my area. I did confirm that. But make sure to double check that. If you live maybe like in the mountains or on the east side of the Great Lakes, a place like Buffalo, New York, there's certainly a wide range of snow loads out there. Snow can potentially add a lot of weight onto a photovoltaic system, so it's important to design the system to be able to support that weight as necessary. In my area, 30 pounds per square foot. We also have to tell the design tool here the pitch of our roof. That's in degrees. If you're used to 412, 712, that rise over run, you might have to do a little math to figure it out. It's going to be right around 30 degrees on my garage. Building height, again, that's kind of important in terms of wind. And I was required to have my garage be no more than 18 feet due to local building codes. So I'm going to put 20 feet here for my building height. Wind exposure, if we take a look at the info bar here, it tells us a little bit about this. Basically, I'm in the exposure B category, but if you're on an ocean coast or out in the plains, you might be in a different exposure category. Risk category is really, it's kind of about flammability of structures, risk to structure. Generally, solar panels are nice and durable and fire resistant, so it's a low risk. The next thing down here is to pick our manufacturer. So right in this list, whole bunch of different brand names, a lot of companies out there making solar panels. For example, a popular one, Solar World. But we're actually going to use my solar panels. Let's scroll down. It's Helios USA. And then pick the model of solar panels. Now, what's funny is my exact model of solar panel is not listed here. It's the 6T260. Well, it's just not here, but I happen to know that this is actually a family of solar panels. They're all the same size, the same shape. They're just a little bit different wattage, so I'm just going to pick the one that's closest to it, knowing that it is actually physically the same size, weight, and shape. Over here for color, that is the color of the frame of the solar panel. Traditionally, most of them are silver, just a plain aluminum finish, but you can also get solar panels that are black. And so the reason why you're even asked this is because typically you want your racking to match the color of your solar panels so that altogether the system looks nice. Personally, I don't know why anybody would want black, because black absorbs heat and it makes your solar less efficient. I do not think that the silver looks bad at all, and it's more common and it's better in the long run for the solar panels. But some people do like the black, just kind of thinking that it blends in a little bit more. So that's sort of a personal aesthetic choice, but from a technical or a practical point of view, the silver is definitely better. And my solar panels have silver frames, so I'm going to choose silver hardware to go with it. So now we'll just hit our big next arrow, and it'll take us from the site into the design. So now in here, we actually get a chance to draw out our array. So I'll select it, and I want to have an array which is 3 rows of 8 solar panels across. So I draw it out, and right away a bunch of stuff happens here. We get some information. So I can zoom in a little bit here, and it tells me some specs: 16 feet 6 inches tall, 26 feet 5 inches wide. If you remember in a previous video using a different tool, it actually said my array would be 27 feet wide, and the reason why in that software it actually did not have my exact solar panel, so I had to use one which was similar, but it was actually just a little bit different width. In this case, here's actually our correct numbers. Now to attach the rails to the roof, we're going to need some attachments. There's a couple different types of attachments available. If you have a typical shingled roof, asphalt composite shingles, this company makes what they call the Flashfoot 2. It's a very, very good product for a shingled roof. Essentially, it's an aluminum shingle with a lag bolt that goes through it, and then a bracket that screws and snaps in place on the top. They're fantastic. They're weatherproof. They work great. They're just not what I was using because I have a metal roof instead of a shingled roof. But for all you people out there with shingled roofs, the Iron Ridge Flashfoot 2, it's a great product. Works very nice. So down here, there are some other options, including flush standoffs. Because I have the metal roofing, I'm going to go with the L-foot only. So I'm going to say, okay, for the Iron Ridge stuff, I just want that L-shaped bracket that will let me attach the rail to the clamp that will go on the metal roofing. Over here for rail attachment hardware, Iron Ridge does have 2 different types. They have a square bolt head and they have a T-bolt. The square bolt, it's nice because it's big, it's durable, it doesn't fall out, but what you have to do is slide it in to the end of the piece of racking. If you get you're putting up your rails, you get somewhere and you go, uh-oh, I miscounted these. Well, you kind of have to start over. You might have to back a few out, add another one in, slide them all over. It can be a little bit of a pain. These T-headed ones are nice because you can just slide them in anywhere, and then they rotate as you drive them in with your cordless impact, and they lock into place. Don't drop them. When you set them into the rail, there's nothing really holding them in there until you drive them in. So kind of advantages and disadvantages to both. And I actually ended up using both on my project I pretty much bought out the stock of the square head ones from my local distributor, and for the rest of what I needed for my project, I used the T-head bolts. So here it says, okay, which one do you want to use? We'll just say T-bolts. Now here's where we're talking about the actual rails themselves. There's three different types, basically small, medium, large. The medium is sort of the flagship product from Iron Ridge, and that is what I chose to use on my project. Now there's numbers here, and these are based on essentially the relative strength of the rails, but you have to keep in mind too, there's already some information created from those wind loads, the snow load, some other information we've already put in the system. And what you want to do is tell the system how far apart you want your attachments to the roof to be. And that's going to depend on how your roof is built. For example, on mine, because I have a standing seam metal roof, I can only attach where those metal seams are. Whereas if you're using a composite roof, you could go pretty much any spot under the shingle, but you still want to make sure then that it lines up with the actual structure of the roof, which might be every 16 inches, might be every 24 inches. It just kind of depends on the roof. But you want to make sure that your attachment span is some multiple of that. With the XR100, theoretically you can span a little over 6 feet with it, and you can cantilever or stick out past the last support of 2.5 feet. So that's nice to be able to do. The other thing is it's a little bit taller than the XR10 racking is, and because of that, it's a little beefier. It also gives a little bit more space under the panels for cooling. So I did 4-foot attachments, a span of 4 foot between attachments. And although I could have done the XR10, I instead decided I was going to go with the XR100. Partly for the cooling. I had also handled some samples of these materials, and I found that the XR10, it would be fine, it'd be appropriate, but it just doesn't feel as substantial as that XR100 does. So I'm choosing the XR100. Now over here, this information is what you want to know kind of engineering wise, and it may be information that a building inspector, for example, would like to know. Maybe he says, okay, what's going to keep this from blowing off your house and damaging the neighbors, or does this weigh so much that it's going to make your roof collapse? Well, here's all the numbers, and these numbers are automatically calculated based on the information we've already put in the system. One of the main ones here, weight, your total system weight. So that's the solar panels and all the racking together. Over 1,000 pounds, but again, it's spread out over quite a large area. Just the racking itself is going to weigh around 128 pounds, and there's going to be over 30 pounds per point of attachment on the system. Now, what's kind of neat too is I've still got the same number of solar panels, but if I change the attachment span, let's say I could attach them every 6 feet. If I change that number, it updates, and we see that our total system weight still about the same. We saved a little bit of weight because we're using fewer attachments. Our weight per attachment went up a little bit, but we're still pretty much the same total weight. However, we would not be able to use the XR10 racking anymore. It's just not designed to span that 6 feet. So we'll go with the XR100 racking. We'll use a 4-foot attachment span. And down at the bottom, we've got one array. They're calling it Array A. A block of panels is going to be 8, but there's going to be 3 rows of them. It tells us how long our rows is. It tells us what rail we need. It tells us how many points of attachment we need, how many clamps we need, and how many splices we need. Now, the other thing here, too, to consider are rail lengths. And the standard ones available through Iron Ridge are 11, 14, and 17 feet. You can also get custom ones. I did not do that. I'm sure that's going to end up costing some extra money to do custom. Also, with stock, they were actually in stock. And using the Iron Ridge page, I found where a local distributor was, and it turned out I had a local distributor only 12 miles away, so I could simply go there and pick them up. So my row is 26 feet 4 inches. I know my entire roof was actually 29 feet wide, so 2 of the 14 foots would get me 28 feet. And of course I need 2 pieces of rail per row of solar panels. There's an upper and a lower rail on each row of panels. So I'm actually going to need 12 panels total. With the attachments and the clamps, we can also see that number change if we, again, let's just say we went with a different attachment span here. So now there's fewer points of attachments. That could save us some money, for example, by having to buy fewer parts. That can save us a little bit of money. So again, in my particular case, going to the XR100 with that 4-foot span was kind of my splurge on the project. I could have gotten away saving a little bit of money and a few parts with a lighter gauge racking or with a longer span, but I went with the extra beefy version, and I've been happy with it. Looks good, works great. So let's keep going. We'll hit the next arrow here. Oh, before we do, I don't want to overlook the fact that although I just had one simple array, I mean, it's just a straight up grid on my garage, you can certainly get a little fancier than that. If we go to arrays, we could add another one. Let's say, I don't know, I've got a shed in my backyard and I want to put 2 solar panels on that. Well, I can just add another array to it. You can go back and forth between the 2 different arrays. You can use different set of attachments on one array than on the other array. You can turn things. There's a lot of other features in here if you've got a little bit different situation than I do, for example. I'm just going to delete that, and we'll go to the next section here. Okay, so at this part, it's showing us our bill of materials. Oh, and let's go back for 1 second because I deleted that second array, but it was still showing up down here. It's clear now. There we go. That's better. So for the rails, we're going to need 12 of those 14-foot rails. We're going to need 6 splices because 2 14-foot rails are going to be connected together to make a 28-foot rail. Here, these are the UFOs are the universal clamps. These act as both a mid clamp and an end clamp. We also need stopper sleeves for the end. We need L-foots to connect from my metal roofing clamps up to the rail. And we need a bunch of bolts to hold everything together. This is what the various rails look like. For the clamps and grounding, here's just an example of the UFO clamps that I used along with these stopper sleeves. Those are used for the ends of the 2 rows. And in this case, I'm actually not using any of the grounding lugs because the grounding for my system is all taken care of through the N-phase microinverters. And for attachments, again, if you have an asphalt roof, Flashfoot 2 is a great way to go. I have a metal roof, so I'm using S5 clamps, and those connect to just slotted L-feet. Over here, it's a price each, a quantity, and a total price. And if you look at this, oh my goodness, that looks like quite a bit of money, which it is. Iron Ridge does cost more than some other systems, but in some cases you also get what you pay for. I think it's a really nice system. It's easy to put up. It looks good. It works well. It's very strong. Also, I'm assuming that these prices here are a full-blown retail price because I did not pay that much money for all these parts. I paid a fair amount, but not that much. Next steps. If we look over here, we've got some download links for some PDF files, the manuals for the components, some drawings, engineering drawings for the components. And up here, two useful ones are the project report and the bill of materials. So if I click the project report, it's going to generate and download a PDF file. It'll just take a few seconds to actually generate that report. Download it. That's going to go in my downloads folder on my computer here. So if I just open that up, we now have a PDF document. And this PDF document has a whole lot of great information in it. It tells all the specifics of my building, wind load, snow load, attachment spacing, the weight of the entire system, weight per attachment, all that different information. This is all information that a building inspector would love to see, that I've done my homework, that I'm not adding so much weight the building's going to fall down, that it's sturdy enough that nothing's going to blow away. And then the actual diagram here will be useful for me for actually installing the racking and the solar panels. Here's just some of the details of the splices, how the mid clamps are used, things like that. Again, a lot of this is actually just kind of for confidence for a building inspector or the utility or anybody else who needs to see, okay, what you're doing is correct and it's going to work out great. This is kind of nice here too. It's a grounding diagram. So in most photovoltaic systems, you need to use a heavy copper cable to connect together the racking and the frames of the solar panel. So here it actually shows how that would be done in this setup. The interesting thing about this too, keep in mind this system uses bonded splices. So even though there's two pieces of racking, the splice between them does electrically bond them. So if this piece of racking is grounded, this piece of racking over here is also grounded. And here's the most interesting part though. For my system, it says very specifically grounding lugs and wire are not required in systems using N-phase microinverters. That was one of the reasons why I use the Iron Ridge system, is that using the Iron Ridge racking and those N-phase microinverters together, I did not have to do any of this work with adding this heavy copper cable and specifically grounding everything that way. It was just a way to save time, cost, and simplify the system. But for most PV systems, you will need a grounding setup similar to this. And the last page here is the bill of materials. It just lists what parts you need and how many of them. So I was able to take this information and then just order these parts directly from a local electrical supplier. So that's about it for the Iron Ridge design tool. It's very useful for that engineering information that you might need to give to your building inspector or your utility. And of course, it lets you know all the parts that you need, so it helps you design that whole system. In this next video, we'll take a look at the solar design tool and how you can use that to create a single line diagram and other information you'll need for your solar system. Until next time, stay charged up.